All right, looks like most everyone is here, so we'll go ahead and get started with today's webinar and online demo for Lantek Expert Punch software. For those of you just joining us, this is Kevin Must, Marketing and Operations Assistant for Lantek USA. First, I'd like to thank everyone for joining us today for this online webinar and demo. Our presenter today will be Lantek USA Technical Director, Tony Barnett. To start, I'd like to take care of some housekeeping items before we get into our demo. So before we begin here, with the large crowd online, we'll keep everyone muted to avoid any echoes and background noises. That said, feel free to send me any questions during the webinar that you may have using the question window at the bottom of the screen. Today's presentation also will be recorded, so I will provide everyone registered with a link to the recording as well as a PDF copy of the slides afterwards. As I mentioned, we will be holding a Q&A session at the end, so feel free to enter your questions through the Q&A box, and we'll go ahead and answer them at the end of the webinar today. If you happen to have any questions that are specific to requirements for your company, feel free to send them anyhow, and we can either reach out offline, or you can send us an email at info.usa@lanteksms.com. So before our demo today, I'd like to introduce Lantek for those of you who may be unfamiliar with us. Here at Lantek, we have over 30 years of experience in the CAD/CAM development and support field, with 20 years of experience in MES and ERP development, support, and integration for metal fabricators. Over the past 4 years, we have been developing advanced analytical tools with a focus on utilizing industrial Internet of Things, or the IIoT, in the past 2. With 20 offices in 14 countries, Lantek currently supports over 20,000 customers in 18 languages while maintaining over 100 OEM agreements. In this time, we've also installed more than 350 MES, MRP, or ERP solutions around the world. So this extensive industry experience has allowed Lantek to understand the pains of manufacturers. 5 pains that we hear most often are reduction of scrap, reduction of rework, quick and accurate quoting, detailed insights or analytics, and maintaining an up-to-the-minute schedule. Our studies have proven that our solutions have helped customers improve every day, and on average, we help manufacturers increase material utilization by more than 8% and productivity by more than 25%. We've also achieved 99% quoting accuracy with a 30% reduction in inventory. And all of this helps us to provide you or our customers with over 40% more on-time deliveries to their end customer. So by providing these different solutions and integrations for all aspects of your shop floor, it helps to create an interoperable transparency across all departments. So from the quoting process all the way through the shipping process, you can see what's happening in each one of your departments. All right, so this leads us into our Lantek Expert Punch demo. So we know that tooling a part can be very time consuming. You know what tool you want to use, but the question is, does the software know which tool you'd like? Also, the punch sequencing can be a bit of a burden. So how can we get the direction you want in less time consuming way? By using Lantek, you can create punch macros to help teach software what tool or tools you want to use for a specific contour. And you can also make tooling common shapes a lot quicker. So to speak more on this, I would like to introduce today's presenter, Technical Director for Lantek USA, Tony Barnett. Tony brings us 34 years of manufacturing experience, with 10 years supporting operators and the last 10 as Technical Director. So thanks for joining us today, Tony. I'm going to pass things off for you so you can control the demo here.
All right, thanks, Kevin. I'm going to switch and share my screen now. Okay. All right, so this is our main screen in Lantek. When you first open up our software, this would be the kind of the first thing you see. So what I'm going to start with here, just initially, is just show you quickly how, if you wanted to create just a standard tool inside of our software, we just go to the Manage tab, we click on the Tools button here. These would be the list of the tools that you currently have in inventory. And when I click on the Create button, this would give us the ability to create the most standard shapes, your rounds, your squares, rectangles, oblongs, that kind of thing. So if we want to create a tool, we pretty much just click on the button that matches the shape, and it will ask us, which value we need to put in here for the length. I actually have that, so I'm going to do this. If there's a radius on this particular square, as we put in the value for the tool, the system will automatically begin to create a reference number. And this would be the name for the tool. You can change this. If I want to name it whatever, I can do that. Also, the type of tool, in this particular case, cut just means it's just a normal punching tool, but you also have a semi-pierce or a press form type tooling that we can choose. We can create dies as we create the punch. So if you want to have the system control your die clearances, we can do that as well. So if you want to force the system into using a specific die clearance for specific material type and thickness, you have the ability to do that, to control that. If not, you can just put in one die clearance and the system is okay with that. Then we can choose what machine we want to create this tool for. So if you have machines on your shop floor that don't or cannot share tools, then we can create a tool specific to a machine, or we can tell it that this tool can fit, in any machine in the shop. And then we can choose what size station that we want to use this tool in. And then say, okay, and it will create this tool. As we're creating tools, it just brings up another option. If we wanted to create another square, it would do that, but I'm just going to close this out here. So that's just kind of how to create a standard tool, and then we'll get into creating special tools in a few minutes. So in our system, to begin tooling apart or messing with your parts, we need to create a job. A job is just a place that you have to bring in parts in order to work with them. You can also create folders to put jobs into, just to help for organizational purposes. So I've opened up a job here, and by default, our system, we can import DXF or DWG files, but we also have the ability, you can, as options, you can get a PDF importer. If you have PDFs, some other different types of importers are available, but the DXF and DWG are what comes standard. I'm just going to take and bring in a part that I already brought in the geometry for. And then I'm going to open that in what we call our drawing module, but it's also our machining module as well. So we open up the drawing module, and this would be the geometry we have that we're going to work with for this particular part. So at this point, I'm just going to go to the machining tab, and I'm going to click on automatic for automatic machining. Here we have some different options and configuration settings. I'll go through a few of them, but to start with, I'm just going to tell the system that it can use all the punches that we have in our inventory. Select OK. So we can see that the system can recognize if we have an oblong shape and we have a tool that matches that, rounds, it knows to tool those directly. If we have a shape that cannot be done with one punch, then the system will try and use multiple punches to do that. You see we're using a round on the radiuses here, and then a square in the middle on this one. On this particular contour, we're nibbling around here and using a square tool in here to finish that out. Down here on this particular contour, we're using a couple rounds, squares, to do this. So the system will kind of do what it can to try and pick a tool. It usually tries to pick the biggest tool it can. And then on the outside corners, you'll notice that it destroyed the corner, and it also went outside the part. And the reason it did that is because of an option we have here we call it one-touch figures. This just gives you the option to tell the software that you want to destroy a corner. If we don't have this checked, I'll uncheck this. What it does is it treats each line individually. And the idea is the system will try and find the longest tool that it has in order to punch that line with that tool. So if we don't want to destroy a corner, we don't have to. We can just let the system treat each line individually. So we have those options in the machining settings, and every time you machine, that window can be prompted to come up, and you can choose different options in there. So before I machine the part or finish machining, the other thing that we can talk about is microjoints. And under our technology tab here, I can apply microjoints to this part. And if we're going to apply microjoints that are going to affect how the tooling is used, then we need to do those first. So for example, if I wanted to put a micro joint on either side of the square corners here in order to create a kind of a shaker tab, then we have a few different ways to do that. I can do just micro joint on one corner, micro joint on a contour, on 2 corners, on 4 corners, or I can make a whole contour micro joint. But so since I know that I want to put it on both sides of this line and both sides of this line, I'm going to choose my micro joint on corners. I just choose the line, and I'm going to make this a little bigger than what would be normal just so that we can see it. So I select OK, and we can see that the little light blue line is just letting us know, along with the dots there, that it put it on there, and I'm going to choose there. And then if I wanted to put a micro joint just on the end of this line here, I'm going to choose micro joint just on a corner, and whichever side I choose closest to, that's the side it's going to put that on. So I will put one there and there and there and over here. Okay. So now when I machine the outside of the part, or machine the part totally, then the system recognizes that there is a micro joint there, so it will stop that punch short so as to not to violate the micro joint. Then at this point, we need to decide, when we go to nesting to nest this part, do we want it to be common nested, where we take one particular size punch, and as we go down between 2 parts, it just takes the 1 row of hits, or a non-common? So I'm going to go back to technology. I'm going to click on automatic, and I'm going to tell it I want to do a common punch between the number ones, and the number ones are just the true horizontal and true vertical lines of the part. And I'll say OK, and the system just changes those colors. It just lets us know that it has applied that technology. And then I will save the part. Now, I have not punched the very outside of the part. You can at the drawing level, but a lot of times we recommend, if you wait till you go to nesting, to apply those. That way, if you're mixing parts, then you can have a common tool to punch the outside. So if you're not mixing punches. So I'm going to go ahead and click on our nesting module, and I'm going to change my quantity here, a few parts, and I'll do a 1 sheet nest on a 4x4 sheet. So at this point, it's done the nesting, and the part has already been machined at the part level. But what we do now is we machine it here, and it keeps what we did at the part level, and now we're adding the outside tool. So I have a horizontal tool for the outside. This is just letting me choose an alternate tool. So if the system can't use the main tool, it has some alternate tools, maybe shorter tools that it could use for the horizontal, and then same for the vertical. And then when it gets at the end, this just shows you your turret layout, what tool is in each station, and whether that particular station is being used or not. And I can select OK, and you can see that the system has gone in and tooled all the part. It's added the outside punching. Up here where the micro joints are, it honored those micro joints. And through settings in the software, we're going to wait to do the outside hits last. If we wanted to change some order in regard to the tools, if we wanted to put the tools in order manually, for example, by default, the system is going to go normally from the smallest tool to the biggest. You can also set it up to do it by turret station. So if you just wanted to start with station 1 and go around the turret, you could have it do that as well. But if you wanted to change some order that it is doing the hits in, I can choose manually the order that I want to do it in up to whatever point. And then after that, if I just want to take the rest that's there, I can move everything else over, just say OK, and the system will just automatically go in and redo that. And as far as the outside hits go, the way I have it set up right now is it's going to do the vertical hits of the outside and then do the horizontal last. So I'll just very quickly in the simulation, just going to back up a little bit here. So you can see right here, it's going to start doing the vertical hit on the outside. All the inside hits are done, and it's going to come down this way and then go back up and around. And then when it gets done down here at the bottom over here, it will go back to the top and then go from the top down and work itself toward the clamps. So there are configuration settings that are telling the system to do this. Those can be changed with different options we have, but that's the kind of the most basic. You'll also see down here where you can see the clamps, and if you have a machine that has different clamp zones depending on the station size, as you simulate the punching here, the clamp zones will change to show, whether you're close to a particular tool or not. The system will also do automatic repositioning. If you do want to nest down in the clamp zones, it will try to reposition to do the part as best as it can, but you also have the ability to do manual repositioning if you want to as well. So that's kind of a quick A to Z as far as just you bring in geometry of a part, you tool it, you go to nesting, you finish the machining there with the outside, and you get your nest and you save it. So I'm going to go bring in another part here. This particular part has some different shape geometry on it. You'll see we have this particular shape here. It's not a standard shape, so we couldn't just create this by going to manage tools in there. So we're going to have to create this shape from the geometry. And I'll show you first of all, if we just tool this the way it is, the system will try and tool it, but it may not use the tool that if you purchase a tool to do this hit, it won't use that tool until we've created it. So what I'm going to do is, to create a special tool, I only want the geometry that makes up that tool. So I'm going to just, in this particular case, I'm going to delete everything else. Now, if you get a special tool from a tool manufacturer, normally they'll send you or can send you a DXF file of that tool, and you can just import that DXF file right into Lantek, and we just need the part geometry, or you can draw it inside of Lantek as well. So I've got my part geometry here. I'm just going to go to the parts tab here and form tools, save as, and then I'm going to choose the center of our contour. Now the center point, this is going to represent where the center point of the tool would be. So again, normally when you order a tool, you're going to know that, or you'll get it with the drawing of the tool. So I'm going to choose the center and just give this a name. You can call it whatever you want, whether it's a cut or form type. Again, whether you want the die clearance and the station type that it's going to be in. And it has created that form tool. So now I'm going to reopen our part that has that particular geometry in there. And now when I automatically machine this, now the system recognizes that it has a tool for that geometry, and it will go ahead and automatically use that tool in that geometry. Now you'll notice in our group of hits that we have here, I have already created, but this uses a gang type tool, I guess, where this particular tool will make 5 hits with the one tool. And this got created just the same way as the special shape down here. We just had the geometry of the 5 holes, and we created it as a special tool and gave it the center point reference. And then when you have a part that has that same group of hits with the exact same spacing, the system will recognize that, and it will use that gang punch to punch those holes. So if I right click on this, you can see that it's selecting all those, that particular tool. And then, so we also have a big round here that it's doing some nibbling on, and a big cutout here that it's done some punches on. But what if the system didn't do something I like, or I don't like the way it punched something, or I just want to change what it did? We have some ways to do some manual punching. So I'm just going to delete what we have here. And so for example, on this circle, if I wanted to maybe punch the middle of the circle out with a square tool and then do the outside with a round tool, I have the option of doing that in our macro instructions here. I can tell the system to pocket the square of an inscribed circle. And when I choose this, it's going to tell me that I have no active tool yet. So I just need to choose the square tool that I want to use to do this with. So I'll choose this 275 square. Now, as I move over near the circle, as soon as I get near that circle, the system will recognize that it is a circle, and it will go ahead and add the group of hits for that square tool. Now, over here, I can choose a round tool that I want to use to do the outside or finish the circle. I'll click on my 625 round here, and I'll go now to our nibble cycles and choose by geometry. And what this is doing is just as soon as I get near a geometry, it will, depending on whether I'm on the inside or outside, it will tool that geometry with that tool. So as I get there, I just select that, and it's now done the square hits and the round hits. Now, at this point, we want to make sure that if it's going to use that combination of tools, that maybe it always does the square tool first, then the round. When we go to nesting and nest it, we could choose the sequencing there, or under our technology tab here, under fix punch order, we can tell the system, I want to do the square first, then the round. And when I select OK, now what it's done is it is, for this part, when we save this part, every time we were to bring this part into nesting and nest it, it's going to keep that sequence of those two tools for us automatically. And then for our rectangle down here, if we want, instead of destroying this rectangle, maybe we want to punch this with a rectangle tool around and leave some tabs in it, we can do that as well. Through our Maker Instructions tab here, we have the ability to do a rectangular hole with micro joints on 2 sides or 4 sides, or we can do one where we actually have to put in a stop or trap. We'll just choose maybe 2 micro joints here. Now I haven't chosen a tool yet, so when I click on this, it's going to tell me that I need to choose the rectangle tool that I want to use. I'll choose a 1/8 inch here. And now as I get near that particular cutout, it will choose that tool. And I'm over here on the right side, I can put in the width of the micro joint. So I'm going to make this bigger just so that we can see it. So I select that, and now you can see it's added the micro joints along with the hits to cut that out. So, and then after we do whatever manual machining we want to do, we can finish with automatic machining. And you'll notice on the corners again, we didn't have it set up to destroy the corner, so it just punched the edges with the biggest tool that it found. If we wanted it to destroy those, I don't want to undo what I did here, so I don't want to delete all the machining. So we have undo buttons here. So I just did an undo of what I had just done, and I could go back to the one-touch figures. I can choose to destroy the corner if I want, and the system will destroy the corners. Now the reason it's overlapping here is because I have a setting here in our one-touch figures. I'm telling it to by a 1/4 inch. That 1/4 inch just matches the width of my parting tool. But if you put 0 in there, then it won't overlap at all. So you can see it's staying to the edge. So just some parameters that kind of help the system know exactly what it is that you're wanting to do with the part. Okay, now let's say that you have a part that some contour or parts of contours on a part are consistent through a bunch of the family of parts, and you want to tool those a certain way, and every time you have that part, you want to tool that contour a certain way. You can do that by creating a macro in Lantek. So for example, if this particular part is one of a bunch that has the exact same corner notch on it, and you want to tool this up a certain way, we can do that and create a macro from that. So similar to creating a special tool, I only need the geometry that I want to make up that macro. So I will get rid of everything else. So I'm left with just what would represent that corner notch. So I'm just going to go to machining and select a punch. We'll just do 275 square here. I'm going to use my manual options to tool this. I know this wouldn't be the perfect way to do it, but just an idea. So I've tooled this the way I want. I can use different tools. It doesn't have to be the same tool. And then I'm going to go to my parts tab, go to machining macros, save as, and just select a reference point. This is just some point on the line there, and call this whatever we want. Okay. So now when we go back to our part, if this would be a family of parts, you know, then when I click on automatic, select OK, you see that it uses that same tool automatically on this part. So any part we bring in that has corner notches of this exact same size, it will use those hits. So it just kind of helps you tell the system how you want to tool a particular piece of geometry. And it can be for corner notches, it could even be for internal contours. We especially use it on when you're doing form tools, which I'll show you that a little bit later. So that's an idea of how to kind of do some manual stuff. Let me close this one. We'll bring in a different part here. This one is a little bit more complicated. Maybe more of a laser part than a punch part, but just to give you an idea, when we do click on machining and machine this, I'm going to turn off those. What the system's doing is, again, it's just trying to find the biggest tool that it can, or if it finds a tool that matches, it will do that tool. And then on the outside, again, it's just trying to find the biggest tool that it can to tool each line individually. And sometimes you'll get something like this where it doesn't have a tool that will fit this, so it just grabs, it'll go down. It basically starts with the rectangle to a square down to a round, and in this case it just used a round to nibble that line. It's not the best scenario, but it's at least trying to punch this. And since I told it that it couldn't punch outside the part, that's why it's doing this. Well, what if I want to allow it to punch outside the part a little bit to help the system tool this part? When I click on automatic machining here, we have some offset values here, and these will tell the system whether, when it's punching a part, whether it can go beyond the limit of the part or not. So I can put in a value in here. The maximum offset is just, it can go up to 1/4 inch, so it doesn't have to go a full 1/4 inch outside of the part, just up to that value. The outside punching offset, if I put a value in here, then I'm putting in and telling the system that I want it to go that much beyond the part, and it has to go that distance. So it would hit however many times it needed to go beyond the part that particular distance. So if I say, okay, now you can see that instead of using that round, it found a rectangle that it could use there, and it's within the limit, that 1/4 inch limit that it's allowed to go outside of the part on. So it did change the tools that it used to punch that, just based on that particular setting. Now let's say that we want to choose a specific tool maybe to do these incline punches here. It's not using the tool we want. A couple ways to do it. I could say I want to delete machining by selection, and I'm just going to select that particular set of tools. And then I can go to our tool list here, and I can choose a tool that I want to use. And then I can, for example, if I want to do just a nibble cycle based on geometry, as I come over here near this particular line, the system will automatically line the tool at the angle needed, and it will apply the hits to that line. So I can quickly change it that way. But maybe there's a tool that I want the system to use. Every time there's an incline line on a part, I want it to use a particular tool. We have what we call predefined tools, and this gives you the ability to, for horizontal, vertical segments, incline segments, inside arcs, outside arcs, inside circles, you can kind of teach the software, or try and teach the software what tool you want it to use when it encounters a particular line segment. So for example, I'm just going to say, well, for this incline line from 0 inches up to, I'll say 5 inches, I want it to use a particular size punch. Maybe the 1 3/8 by 1/4, and I'll select OK, and OK, and OK. So now if I right click on any tool, it will give me, and go to properties, it will tell me what punch that's being used, and it will also let me know the XY coordinates of the tool. Just give me some information about what it's doing there. So by using predefined tools, we can also try and teach the software what we're wanting to do. So macros would be one way. Predefined tools is another way that we can use to kind of teach the software what we're wanting to do. Some other options we have after we have tooled apart with the tooling, and I showed you we can right click and go to properties to get some information about the tool. We can also right click on a group of tools here, and I can tell the system whether I want to shorten this group, this particular hit by a value, lengthen it, or if I want to go to a certain point. If it's a nibble like this is, I can change strokes and go to tolerance. So if I wanted to make that scallop a little bit smaller, I can change my T value here, and you'll notice if you watch this, it should change by, it's adding some more hits in there. So I've just kind of tightened that up a little bit. You can do the same thing in here. I can tell it to shorten or lengthen this by a value if it's a rectangle or something like that. So any group of hits here you can right click on, and there's some options in here that you can do to change what the system has chosen. So even complicated parts, the system does a pretty good job of trying to find the tools. And again, it's just going to try and find the the longest tool it can to tool apart. All right. So let's see. We'll bring in another part here. I have. Just some different scenarios in it. This particular part here, this part actually has a form tool in it, and I have this particular geometry just representing that form tool. Our system, you can create a special tool from and make it a form tool, but the geometry needs to be connected geometry. So you really can't just take a bunch of crossing lines and say, okay, create a special tool from that. It needs to be closed geometry. So something like this or that other one I created the special tool from. So in this case, I already have this created, but I'm going to go ahead and machine this. And what scenario I'm going to show you right now is, if this were a form tool here, and we go to nesting, and we use a rectangular tool to cut along the top side here, if we do that rectangular tool after we've done the form, then we run the risk, because these are so close to the edge, of mashing those forms back down. So we want to sequence this so that it will do the forms before it does the punch on the outside. Well, if the outside punch were a completely different punch on this side than it's using for the other three, that wouldn't be too difficult. We could just use our order punches manually and put them in the right order. But in this case, it's going to punch with the same punch all the way around. So we need to then kind of tell the system, well, you need to do the two sides, do the top, and then come in and do the form, and then come back and do the bottom. So I'm going to go ahead and finish adding my technology here to this. So I've got the punching, got the technology. I'm going to save it. Okay. And I'm just going to manually throw this on a sheet. Okay. And we will machine this like we normally would. Okay. So now this particular sequence, I haven't changed anything. So you'll notice it's going to punch that form, and then it's going to wind up coming back. And it's possible that it could mash those back down. Well, we have an application that we can run, avoid collisions with forming operations. I'm just going to click on that button. Now there are some parameters that in the background, configuration parameters that you can put in. How far away, does it need to be from a punch before you have to make a change, that kind of thing. But now I'm going to run the simulation, and the system will then come in, and it does the outside here, there, comes in and does the form, and then it'll come back and do the rest of the outside. So the system knows by looking at this that this is a form tool. When I created it, I told it was a form tool, and we have some options that when it encounters that, if you have another punch close to it and you run that application, it will try and separate those hits for you. Another part I have is just another little scenario showing how to kind of resequence things. So this part here, I already have this one tooled. This is just a group of a bunch of hits here. And I'm going to go into nesting with this. And again, I'm just going to just do it on a sheet here. So I'm going to finish machining this. Okay. So by default, what the system is set to do is to start with the closest hit from the front point. And then right now we've got it going up and across like this to do the hits. And it's just finding the next closest punch. So it may not do that sequence exactly the way you want. Maybe you want to start down here on the left and go this way with it. Or maybe you want to punch across, rapid back, punch across, rapid back. So how do we get the system to sequence this the way we want? After we've done the machining here, we can go to machining, modify. And in modify, I have options in here to do different things. I can reverse the structure of the punch. I can increase strokes, decrease strokes. I can modify my nibble cycles, quite a few things. But in this particular case, I want to go to order machining, order punch sequence by window for the selected tool. And I'm going to select the round. And I'm going to put a window around all of those hits. And then our order mode option comes up. So if I want to start, for example, in the bottom left and have it go over and up, I click on this one. This number of strips, it just breaks the sequence down into very small strips so that as it's going across, it's not looking very far away for the next hit. The lower that number, the farther away that it will look to find a hit that's within that realm. So in this case, I'm going to start here and it's going to go across and back up. Maybe I want to go across and then wrap it back. So another option we have that was in that same order machining window. Put a window around it. Is I want to, this one here, this showing the dotted line, that's showing me that it's going to punch in this direction, wrap it back, and punch across. So I can choose that, say, okay. Now when I simulate, you see it's going to wrap it over and come back. So in that machining, order machining window are different ways to get it to do it pretty much automatically. We can also, if you want, you can order the punch sequence completely manually. If I want to come in here and choose, I want to go from that hit to that hit to that hit, all the way around. So you can also do things very manual as well as automatic. It kind of depends on how you want to do them. So it looks like we're getting near 40 minutes here. So I'm going to stop with what I've been talking about here. I think I've covered most of it. And we will talk about, see if anybody has any questions or answers, or questions, and I'll try and give the answers.
All right, awesome. Tony, thank you for doing this little demo for us. I'm sure that our participants really enjoyed it as well. We did have a few questions come in. So before I turn that over to Tony to answer your guys' questions, I would just like to remind you all that we are recording this and we'll send a link out. So keep your eyes peeled for early next week to receive that link if in case you'd like to share it with some coworkers or colleagues of yours. Also, if you have any specific questions, feel free to email us again at info.usa@lanteksms.com. Give us a call at 877-805-1028, or you can respond to the invitation email that I had sent out with any questions, and I'll be sure to pass that along to the proper people to answer them. So with that said, I'm going to go ahead and turn this over to Tony so he can answer any questions that were had here throughout our demo.
Okay, thanks, Kevin. Okay, so we have a question: for which version is the one sheet nest new? 2016, 17, or 18? The one sheet nest should be in all three of those versions. I don't know when it came out, but definitely if you've got version 16, 17, or 18, you should have the ability to do the one sheet nest in it. You have the one sheet nest, and then you can do grid nesting, dynamic nesting. The dynamic nesting is a purchasable option. So you have manual nesting that would allow you to do a new sheet and then do manual nesting or grid nesting. If if you have our full nesting package, then the one sheet would be available along with what we call do all. So if you're a current customer and you want us to kind of show you that, you're more than welcome to call in on our support line, and any of our technicians will be able to kind of show you that. We also had a question about whether you can copy machining. Yes, you can. You can tool up a particular contour within a part the way you want manually, like some of the tools I was showing you. And then in the machining tab, you can go modify copy machining and select the tools that represent that geometry that you tooled, and it will copy that to all of them. So if you have a bunch of one geometry, a particular geometry within a part, and you don't want to have to do those all manually, just do one of them and you can copy the machining to them. The other question was, do we have the ability to use an actual microjoint tool? Yes, we do. You create the tool as a special shape, and then we have a configuration option that will, you can tell the system that when it sees a microjoint, to use that microjoint tool, and it'll put that microjoint tool on either side of the sheet. Let's see. Oh, can we punch two tools over one tool? The answer to that is yes. So, for example, if you have like a Tiernerman or a form that gets a hole punched in it and then it gets formed up, for example, we can either do that kind of semi-automatically, where you would do the punching and then we have a punch over another option where you can tell it to punch. You choose the tool that you want to punch over, or you choose the tool you want to punch and then choose which tool you want to punch over with. Or you can create a macro and you can punch both punches on the geometry that you want to do it with, and then create a macro of that. And then the system, when it sees that particular piece of geometry, it knows to use both of those punches on that geometry. And then you can also choose the order, making sure that the system does the hole first before it does the form. So we can do that as well. And then I think we got another question here. Wheel tools. Yes, we have done the wheel tools. In our tool creation window, one of the options is a wheel. And when you click on that, and you can choose the different types of wheel options there. You can do the rib wheel or the cutoff wheel, the marking wheel, those kind of things. And the system will generate what it needs, but then most of those obviously would be post-processor specific, as far as we need to make sure that we get the right code in the post-processor in order to run the wheel the way it needs to be run. But we have done those for a few different machines. So looks like, is that all the questions we got, Kev? Okay, I'll send it back to you.
All right, so again, thanks everybody for attending today's session. We'll go ahead and email this out. And if you have any questions, don't hesitate to send us an email. Or if you'd like to see a specific demo of this software that's a little more tailored for your requirements, feel free to reach out to us and we'll get something scheduled. So that wraps it up for us, and we look forward to hosting another webinar here in the near future. Have a good day.